Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. Now, take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Product Killer by Richard, and here are the rules. Apply classic Sudoku rules, which means fill every row, column, and box with the digits 1 through 9 without repeats. The small numbers in the upper left corner of each cage, which is a dotted outline region, indicates the product of the digits in that cage. And there's no need to worry about repeats because those are already covered by the how do you say it? By normal classic Sudoku rules. So the product of each cage must multiply to the digit in the top left corner of the cage. So the product of these three digits is 240. The product of these three digits is 84. The product of these three digits is 36. The product of these three digits is 15. The product of these two digits is 8. So as an example, this could be something along the lines of 8 and 1, which multiply together to multiply to 8, or it could be 2 and 4, because these two digits multiply also to 8. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, so for me, the things that comes straight to my mind are the 15s. Because 15 can only have, if you take the factorization, I think that's the term. Yeah, the factorization of 15, it's 3 and 5. And that's the only combination of digits you can have there. So this is always 3 or 5. And if you have 3 of them, you have to have a 1 multiplied with it together. So this is 1, 3, or 5 here. Well, we know we have a 1, 3, 5 triplet in row 7, which eliminates 1, 3, and 5 in the rest of the row. So in row 7, where's the 1? It has to be one of these two cells, which means this cannot be a 1 here. If this were to, again, the factorization of 8 is 2 times 2 times 2, which means it's either 1 times 8 or it's 2 times 4. Well, if it's 1 times 8, this would have to be 8, and this is 1. If it's 2 and 4, it could be either of those. Factorization of 12 is 2 times 2 times 3. So it's either 126, 134, and there's no other factorization that would work. So 1 has to be in this 12 product cage, no matter what. 32 is 2 to the 5th power. You can't have 2 times 16. You can only have 4 and 8 here. So this is 4 and 8 multiplied together to multiply to 32. Right? Because you have to have five twos worth of product. And the only way you can get that is 4 times 8 in normal Sudoku. 24. 24 is 2 to the 3rd times 3. So it could be 3 and 8 together, or 6 and 4. So this is 3 and 8, or 6 and 4, right? The 12 again is either 126 or 134. Huh. I don't know if that tells us anything. Okay, what else do we have? 252 is unusual. Actually, 84 is also unusual. Maybe we should do 84s because there's two of them. 84 is actually 210 is unusual also. 210 is a factorization of 3, 7, 2, and 5. Oh, so that has to be 5, 6, and 7 then, right? Because 5 and 7 are you cannot have multiples of those in normal Sudoku digits. So those have to be by themselves, and the remaining digits are 2 and 3. So it has to be 5, 6, and 7. Which means this is 3, this is 5, this can't be 5 here. This is a 1-3 pair. Therefore, this is a 5. 5, 6, and 7, yeah. It's 30 times 7, right? 84 again is a factorization of... It has to have a 7. And it's 12 with it? Is that right? 7 and 12. Okay. So that means it's 2 to the 2 squared and 3 and 7. So it's 2, 6, 7, or it's 3, 4, 7, right? Because it's 12 essentially. Right. So the 7 is here either way. And it's 12 times that. So this is 7 either way. With 2, 3, 4, or 6. This can't be 3 though. So if it's 3 and 4, this would have to be 4, 7. This would not be 4. This is 36 though. Okay. That means it's 2 squared and 3 squared. 2 squared and 3 squared. Can't be 6 times 6, obviously. It could be 2 times 3 times 6, but then that would eliminate all possibilities for this 84 product cage. So it cannot be 2, 3, 6. I think it has to be 1, 4, 9, right? You can't have 12 and then multiply. Like, if you have 3, 4 times 3, that doesn't work. You can't have 2, 6 times 3. So it almost has to be 1, 4, 9, right? Okay, so the factorization is 2 squared and 3 squared, right? That would give you potentially 2 with 18, but that would be 229, which is not, obviously, doesn't work in normal Sudoku. And then 236, which would break this 84 product cage. So that's not allowed. So you can't have 2 by itself. That means you need to have 4. And you can't have 4, 3, 3, because again, that breaks normal Sudoku. So then it has to be 1, 4, 9. So this is 1, 4, 9, which eliminates 4 as a possibility. Therefore, this must be 2, 6, and 7 multiplied together, right? 12. 2 and 7 is 14 times 6 is 84. Or 2 times 6 is 12 times 7, which is 84. Therefore, the remaining digits are 3, 5, and 8. Not 7. 3, 5, and 8. This can't be 3. This can't be 5. Okay, 252. 252, the factorization is obviously a 9 in there because the digits add up to 9. So it's 27 with it? Is that right? Not, no, 252 divided by 9 is 72. So 28. Oh, well, there you go. It's 4, 7, and 9 then. Right? 4 and 9 multiply to 36 times 7. 7 times 6 is 42. 7 times 3 is 21, so that adds up to 252. Yeah, so this is 4, 7, and 9, which means this cannot be 4. So either this is 1 and this is 8, or this is 2 and this is 4. So this is 4, 7, 9. 240 is also very unique because it's a lot of 2s. 8 worth, I think. 2 to the 3rd power. It's 3 times 8 times 10. Oh, that's 2 to the 4th. Right. So you need a 5, which can only be 5, because that's the only digit that has a factorization, or that's a multiple of 5, between 1 through 9. So you have 240 divided by 5, which leaves 48. And 48 has to have 6 and 8. So this is specifically 5, 6, and 8. This can't be 6 because we know we have a 6 here and we have a 6 here. So 5 times 6 is 30, times 8 is 240. That's the only factorization. Therefore, this can't be 8. This must be 4, which makes this an 8. Therefore, this cannot be 8. And therefore, this can't be 3 here. These both can't be 4. So this now, where's the 4 in this cage? It has to be here. So these can't be 4. Therefore, if this is 3, 4, and 7, the 4 has to be here. So 3 cannot be here. We have a 1, 9 pair here. Okay, what else do we have? 24. 24 is, again, 3 times 2 to the 3rd power. So if it were 1, 3, and 8, the problem is neither of these could be 1 or 3. So both of these would have to be 1 or 3. So it cannot be 1, 3, 8. It could be 1, 4, 6. That's possible if this is 1. So this would be 1 and this would be 4, 6 if that's the case. 2, if you have 2, it could be 2, 3, 4. So this could be 3 with 2 or 4. So I think 4 has to be here no matter what. You can't have 8, so you can't have 8, 3, 1. So it's either 1, 4, 6 or 3, 2, 4. And 4 has to be here either way. So this can't be 4 here. One of these is a 4 then. This can't be 4 because of this 4, so this must be 8, and this has to be 1. This can't be 8 anymore, so this must be 5, which means this can't be 5. These can't be 5. Therefore, they form a 6, 8 pair in box 4, which eliminates 6 and 8 in the rest of the box. It also eliminates 6 and 8 in the rest of the row, so these can't be 6. Therefore, this must be a 6 here. This can't be 5 because of this 5, so this must be a 7, which means these can't be 7. This is a 5, 6 pair. This can't be 7 because of this 7. The remaining digits in row 4 are 2, 3, 7, 8. This can't be 7. Can't be 3, so this is 2 or 8. This can't be 8, so this is 2, 3, or 7 here. We have 90 also. We need a 5. And the 5 has to be separate. So then it's times 18. So the 5 has to be here. This can't be 5. And we need 2 and 3 to the 2nd power. 3 squared. So we need 18. We can get that through 3 and 6 or 2 and 9. So it's either 5, 3 and 6 or 5, 2 and 9. Well, 7 is one of these two cells, which means 7 has to be one of those 3. Um, the remaining digits in row 6 are 1, 4, and 9. So this can't be 4, so this is 1 or 9. This can't be 1, so this is 4 or 9, and this is 1, 4, or 9. The remaining digits here have to be 1, 2, 8, and 9. Oh, we do have a 4, 9, 4, 9 pair in column 7, which eliminates 4 and 9 in the rest of the column. This can't be 9. So if this is 2, 5, and 9, the 2 has to be one of these. So this cannot be 2. This is 1, 2, 8, and 9. And this is 1, 2, 3, 8, and 9. Can't be 8, though. Because one of these is 6 or 8. Rest of box 9 has to be, what, 2, 3, 6, and 8. Well, these can't be 3. These can't be 8. This can't be 3. Where's the 3 in box 9? It has to be here. Can't be 3 because of the 1, 3, 1, 3 pair there. This is 3, which means this cannot be 3. So 3 has to be one of these 3 cells here. What about the remaining digits in box 8? They are 2, 4, 6, 7, and 9. This can't be 4, though. This can't be 6. And this can't be 4. So one of these two is a 4 here. Where can 8 be in column 3? Cannot be any of these cells because of the 8 in the box. Can't be the. It can only be here if that's the case. It can't be here because of this 8 can't be in the cage. So it has to be here. So this is 8, this is 6. Which means this cannot be 6 here. This can't be 6 here. If this is 1, 2, 6, the 6 has to be here. So this can't be 2. Where is the 8 in row 7? Can't be here because of this 8. Can't be in the cage because 8, we know it has to be with 1 and 3. And therefore, this would have to have a 1 or 3 here, which is not possible. Can't be any of these because of this 8. Can't be here because this has to be 4 times 7 times 9. So 8 has to be here, which means this can't be 8. That forces a 2, 6, 2, 6 pair in column 9, which eliminates 2 and 6 in the rest of the column. So this can't be 2, it must be 8, which means this can't be 8, this is 3, which means this can't be 3, so this is 8. This 3 eliminates 3 in the rest of the row. We now have a 2, 7, 2, 7 pair in box 4, which eliminates 2 and 7 in the rest of the box. This can't be 2, so it's a 1, 3, 9 triplet. This can't be 8. This can't be 2. Where is a 2 in box 6? It has to be here. So this is 2. Therefore, 2 has to be one of these cells. So this this cannot contain both 2 and 3 because that would just wouldn't work. Again, it's 3, 6, 5 or it's 2, 5, 9. So this is the other 2 or 3 here. The remaining digits here are 7, 4, 1, and 9. Okay. Okay, 4, 4. Okay, this can't be 3 because of this 3 anymore. So this is a 1, which makes this a 3. The 3 has to be one of these 3 cells here then. Um, one of these is an 8. We also have a possibility of 1, 6, or 9 here. Because both 4 and 7 are here. Um, hmm. This can't be 6. So since this can't be 6, this can't be 4 because it needs to multiply 24. So this is 3 or 6. Again, so if this is either 1, 3, 4, or this is 1, 2, 6. So 3 and 6 cannot be in the rest of the box. We know 1 can't be in the rest of the box, and 8 can't be in the rest of the box. So the rest of the box must contain 2, 4, 5, 7, or 9. This can't be 5. These can't be 4 here. Hmm. The rest of this. Where is the 8 in column 4? It has to be one of those two cells. Um, the rest of row 7 is 2, 6, 7, 9, right? Because it cannot have a 4. So that's still fine. 5 is one of these two cells. 1 is one of those 3. 3 is also one of those 3. So this is 1 and 3 here. Remaining digits here are 2, 4, 7, 8, 9. But 7 cannot be any of those cells. So 7, this can't be 8. Huh. Five has to be one of these two cells. Okay. Well, that's not that helpful. We know 5 has to be one of these 3 cells, which is in row 1 or row 2. We know 5 has to be one of these 2 cells, which is row 1 or row 2, which eliminates 5 in the rest of rows 1 and row 2, but that just means one of these 2 is 5, which we kind of already knew anyways. So, um, hmm. Hmm. Again, to get 84, it's either 2, 6, 7, or it's 3, 4, 7. Therefore, 8 and 9 both have to be here. Because one of these is 2 or 4. So this is either 267 or it's 347. And if we had another 2 or 4 in the box here, the problem is that then both 2 and 4 would be eliminated here, which would force all 3 of these cells to be 8 or 9, which is not allowed. So one of these is 2 or 4. One of these 3 is 2 or 4. So both 8 and 9 have to be here, which means this cannot be 8 or 9 in the rest of the column. So this is one of these 2 is a 9. We know one of the ones is here. Aha. This, where is the 6 in box 1? It has to be one of these 2 cells. Because it cannot be here. It's either 126 or 134 here, which means the 6 has to be in one of these 2 cells. Which means this can never be a 6. So this is specifically a 2-4-2-4 pair. Well, 2-4 needs a 3 to multiply to 8. Or sorry, to 24. So this must be 3, which makes this a 2-4 pair. This can't be 3 anymore, so this must be 6, which means this is a 4. This 6 means it can't be 1, 2, 6 anymore, so it's 1, 3, and 4 here. So this is 1, 3, 4. This can't be 3. This can't be 4 here in either of these places. This is 2 and 4, so this can't be 2. This can't be 2. These can't be 3 anymore, obviously. One of these 2 has to be a 3, so this can't be 3. Cannot be 3, which forces this to be a 3 here. This is a 4, so this cannot be 3, 4, and 7 multiplying to 84. So it has to be 2, 6, and 7 here. This has to be an 8 because that's the only place for it in the column. This has to be a 9 because that's the only place for it in the column. So this can't be 4. Where's the 4 in box 8? It has to be here. This is 2, 6, 7, which forces this to be 3, which makes this a 2. This can no longer be 2, 5, and 9, so this is 3, 5, and 6. The remaining digits here are 1 and 5. We have a 1, 5, 1, 5 pair in column 5, which eliminates 1 and 5 in the rest of the column. Therefore, this can't be 1. This is 9. This is 1. This can't be 9. This is 3, 5, 6. So the rest of the 6s cannot be in the same box. One of these must be a 3 because in column 7 we have a 3, 5, 6 triplet, and the 3 is only in one of those 2 cells then. So this can't be 3. This is 5, 6. We have a 5, 6, 5, 6 pair here. This can't be 8. Therefore, where is the 8 in box 3? It has to be here. This can't be 4. This can't be 2. This can't be 9, and this can't be 9 because of this 9. So we have a 2, 7. Well, actually, we have a 2, 6, 7 triplet in row 3, which eliminates 2, 6, and 7 in the same row. So this can't be 6, which makes that a 5. This can't be 5 or 6, which makes that a 3. This must be a 6. This can't be a 6 then. This can't be 7. This can't be 3. We also have a 2, 7, 2, 7 pair in column 3, which eliminates 2 and 7 in the rest of the column. This can't be 2, so this is 4, which makes that 2. This 4 means this can't be 4, so this is 1, which makes that 4, which makes that a 3. This 1 means this can't be 1, so this is 5, which makes that 1. This can't be 1 because of this 1, so this must be a 9. These can't be 1 anymore. It can't be 9. So this must be a 7. This is a 4. This is a 1. This can't be 5 or 9. This can't be 7. This has to be a 9 remaining in column 3. This can't be 1, so this must be 9, which makes that a 4, which makes that a 1. This 4 means this can't be 4, so this is 9, which makes that 7, which makes that 4. This 5 means this can't be 5, so this is 6, and this is 5. This can't be 9 anymore. Where is the 9 in box 8? It can only be here. So this is 9. This can't be 7 or 9, so this is 6. Here we have 1 and 8 remaining, but this can't be 8, so this is 1, which makes that an 8. This 1 means this can't be 1, so this is 9, which makes that a 1. This 9 means this can't be 9, so this is 5, which makes that 9. One of these has to be a 7, because this can never be 7. So this can't be 7 anymore. That makes that a 2, which makes that 7, which makes that 2. Which means this can't, neither of these can be 2. This can't be 2, so this is 6, which makes that 2. This can't be 2 anymore. This is a 2, so this can't be 2, which makes that 7, which makes that 2. Therefore, that's a 7, which makes that 2, which makes that 7, 6, and 2. Therefore, this can't be 7 here because of this 7. So this is a 6, which makes that 7. And we have 5 and 7 remaining. This can't be 5, so this is 7, and this is 5. And that's the solve. I'm not sure why. It was a little hairier, actually, than I thought it would be with product killers. I will say I'm not used to, essentially, the products of digits in cages. So maybe that's why it felt a little hairier. But also a little bit of Sudoku felt a little hairier there too. I don't know. I'm not sure what it was exactly. It's always cool finding little variants of puzzles. So makes sort of makes you expand your brain a little bit on what possibilities there could be. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.